So this is my astrology program. Um, for the most part, we have 30 degrees per sign. When it goes off the right edge, it comes onto the next row down and starts again. It's just like reading a book from left to right, top to bottom. When it gets over here to Pisces and it comes off the edge, it starts back up here at Aries. Now that's true for the sun and moon. It's not necessarily true for all the rest of the planets because the planets can end up in retrograde, and we can see that happen if we go month to month. So here's Mercury and Mars. Let's see if we can find a Mercury retrograde. So if we, I don't know. So this is astrology for astronomers, as if they'd care. But I'm going to try it anyway. So behind the scenes, this is got all the mathematics that they use at NASA. So if we look at the source, up here is the so I got this all stuffed into one HTML file. So we're starting with CSS, and that's how I get my tables to show up. So here we start the JavaScript, and I'm setting up like the days out of each month, and I account for the leap day. It's in here, and so all the way down. So here I'm going through all the aspects. I'm comparing all the angles with all the celestial objects. We have a natal chart and a transiting chart, and then I compare both charts. So if we go to the nitty gritty on how the planets are aligned, just so we're on the same page. Get down enough in this code. We're still doing trig functions. Yeah, here we go. So here's the sun's position. And let me blow it up a little bit bigger. There's moon, sun, a little bit bigger. Luminary positions displays sun. So, I want you astronomers to take a look at these orbital elements. Now, this says for the sun, but it's really the Earth going around the sun that these are for. You just have to change a sign or two to get it to work right. And so I'm doing that calculation, and then here's the moon, and the moon's calculated in a slightly different way. We have to do a little bit of calculus to figure out the value for see, we can't find the value exactly on the first pass, so you have to do a few passes here to get this all to come up with the right answer. It's a bit of calculus, but that's how you do calculus in programming. So you iterate until the epsilon is smaller than the desired value. And then what we have is x and y on the ecliptic, and then here's the radius. You can see we're squaring x and y, and we're adding them together, and then we're finding the square root to get the radius. And this is probably the velocity or something. I'm not sure. But I made this some time ago in a different language. and the language became antiquated, and I had to shift my logic all over to JavaScript. And here we're adding V and W. So these are the orbital parameters for Moon, and then you can see down here we're doing adjustments for the Jupiter and Mars, or Jupiter and Saturn displacements. This is Saturn. You can see we've got a few factors here. So we have, so we're calculating these things from accepted values that I'd seen published on the internet. I know that's a crazy place to get it, but it's the only place you can, in this day and age. Either that or you buy an expensive $500 book to find these values. So I'm not trying to foul these numbers up. I played with them a little bit because I was getting erroneous results, but I found out later that was because of a variable name that I used in two different places for the same thing. And it was a global variable. I know you're not supposed to use globals, but sometimes they're the easy way out. So here's Mercury. Here's Venus. Here's Mars. Here's Jupiter. And see, we're taking into account these perturbations with Saturn and Jupiter. So they're interacting with each other beyond just the orbital parameters. This will give you an ellipse that's in the right place. But unless you take into account the gravitational influence of Jupiter and Saturn, it won't come out right. And same here for Saturn. Same here for Uranus. And you'll see me using, this function A and function B. I'll show you those too. I want to make sure I'm getting the right values here. And here's this. Here's Pluto. Now, I know you guys don't count it as anything. It's a ice ball way out in the distance. But Pluto shares a couple characteristics that's pretty similar to our moon. And I'm thinking they're quantumly entangled to some degree because they exhibit the same properties. So you'll see in some of my other videos that Moon-Pluto conjunctions and squares can do some rather strange things to people. And here's function A. So you can see I'm taking values for X and Y in the ecliptic, and I'm finding the distance, and then I'm finding V, and then I'm adding W and V together. Those are in the parameters. And then I'm getting a three-dimensional rectilinear position from a polar coordinate, and this is probably relative to the sun. I think it's relative to the sun. So I'm getting three components, and then I'm going back the other way. After I get all this calculated, I put it into rad, long, and lat, and then here we have B, where it's taking the rectilinear coordinates here and adding the position of the sun to it, so you can see it from a geocentric position rather than from a solar position. And we're looking at it from the Earth, and then we're finding again radius, longitude, latitude. This is for an adjustment to get the local time. I'm calculating with time zones. Hope you don't mind. It's just a number. And then back into rectangular coordinates. And here we're finding X. Here we're finding Y. Here we're finding Z. And again, this is relative to the Earth. So you can find azimuth and altitude. I'm not using these, but they might come in handy later when I'm doing houses or trying to line it up with the celestial constellations rather than the astrological. But yeah, all that might matter. And astrology takes it into account, believe it or not, with their way of doing things. I have my own way, separate from theirs. But I found it works real well. A lot clearer to understand what's going on in the chart. And I don't use all the crazy symbols. I know some of you scientists, astronomers, they use the actual stars. We don't care too much about the stars. You know, December is the same 3,000 years ago as it is now. The only difference is you might be in a different location of the Earth, and so December means something different for you. But 3,000 years ago, December was like December is now. So all this baloney about, oh, the sun comes in and it Euchiofis, Okiufans. Are there any Ophiuchans out there? So check my numbers for me. I need a peer